I'm Harry Atwater, faculty member in Applied Physics and Material Science and Division Chair for Engineering and Applied Science. It's my pleasure to welcome the portfolio of KNI directors to this.
We've been reduced to a portfolio.
Well, portfolio is a very diverse thing, so we'll start with that. So joining me are from your left to right are Professor Michael Roukes, Professor of Physics, Professor Axel Scherer, Professor of Electrical Engineering, Professor Nai-Chang Yeh, Professor of Physics, and Professor Julia Greer, current director of the KNI, Professor of Material Science, Medical Engineering, and Mechanics. And so what we wanted to do was to open and use this opportunity of 20 years of knowledge harvesting to learn about the lessons learned and try to chart the course for the future. So I wanted to start with, we'll start from left to right, and ask each of you, starting with Michael, to spend just a couple of minutes reflecting on your own experiences as director. Of course, Michael, you were a founding director, so tell us about the early days and what was the original vision and the glimmer in the eye before it all existed at all.
Great, thank you. Thank you for the opportunity. First thing I want to do also is give my thanks to both the Kavli Foundation and the Moore Foundation that made this last 20 years possible, the advent of institutionalized, maybe that's the wrong word, neuroscience at Caltech. So the backdrop of our initial effort is the following. Several of us separately had created our own nanofabrication, microfabrication facilities at Caltech. We had our own clean rooms. I had mine, Axel had his, Yu-Chang Tai had one. And these are expensive enterprises to run as a single investigator. On top of students, equipment, materials, and supplies for doing the research, it cost millions to actually install the equipment. Axel and I collaborated on getting equipment for our own labs in the early days. But it took somewhere upwards of $500,000 a year to actually run our own independent clean rooms. The only way I could sustain this as a professor was basically to let my group grow. And in my 40s and 50s, I kind of lost my way a little bit. My group grew up to almost 50 people, and that caused a lot of administrative work. And I even had one former graduate student who's sitting in the audience here. He's actually a chief scientist for the AWS quantum computing that staged an intervention in my group saying, we can't get papers out, because I wouldn't let papers go out of my group. So I was so burdened with administrative work that, by saying I lost my way, I'm thinking of two august people in the science and technology realm. Richard Feynman talked about the joy of finding things out. And for an experimentalist, that's found by being in the laboratory, being really close to the laboratory, not being a science administrator. And the other part of it is Steve Jobs said, it's not the destination, it's the journey. And to be part of that journey, you have to have your feet on the ground in the laboratory. So, thanks to the Kavli and the Moore Foundation, we were able to create a vision for collective neuroscience, supportive collective neuroscience at Caltech, and had the funding to create an institutional level enterprise, which I have to thank Axel and Guy DeRose, who more than 20 years ago really had the founding vision for our technological infrastructure at Caltech. So I'll leave it at that. It's just been wonderful to have this opportunity over the last 20 years to slowly get back into the lab, to reduce the size of my group, and to re-engage in the joy of finding things out.
So, Axel, you've made some and observed some of the smallest structures, and in your role as KNI director, what were some of the things that you noted and championed?
Yeah, I think it's been a great journey for the last 20 years. I also want to thank the Kavli Foundation and the Moore Foundation. They both got us started. And before that, it was the NSF. So we bought a beam writer together. Michael and I ended up realizing that we were making structures over larger areas that our home-built lithography tools weren't up to. And so we sent a proposal to the NSF, and we actually got funded for a beam writer. And then it was left up to me to figure out how to get it into the lab. And that's what started the whole effort. You think about the costs of maintaining these things, it really is prohibitive for a single faculty member to maintain over a long period of time. At that time, in 2003 or 2004, in my lab, we were just starting on the silicon photonics area. And we also needed to build much more complicated systems. So we had to build modulators, for example. And I remember we built our first modulator, and it was amazing. It was multi-level lithography, and we couldn't have done it without that beam writer. So that, to me, showed the capabilities that were needed to go to the next step, to not be just simply making small things, small devices, but actually building systems that worked. It required that complexity. And I think that is what the KNI has allowed us to do, to become more ambitious in building systems rather than individual devices and so on. And so nowadays, I'm trying to go to the smallest possible structures, truly nanoscale, where we think about 2 or 3 nanometers as being the whole size of the structure. And I think hopefully that'll feed into the next generation of the next 20 years of the KNI.
Awesome. Okay, so Nai-Chang, I guess by the time you took the director's seat, KNI had grown up from being a toddler to maybe even beyond an adolescent to being a full-blown Kavli Nanoscience Institute. So tell us about your term as director.
Yeah, it was a very interesting experience for me, also a growing process for me. I was lucky that these 2 directors, they already established a pretty good lab. But then when I took over, together with Oscar Painter, so I want to acknowledge him here. We were 2 co-directors. Unlike these people, I had another partner, so we always joked about it that we could share the work and also share the blame. So it was nice in that sense. And so together with Oscar Painter, we looked at what we had at that time, and we felt that we wanted to make KNI to be an intellectual hub for nanoscience and nanotechnology on campus. And then also we had to think about how to sustain the state-of-the-art instrumentations. And then another area dear to me, to my heart, was that I wanted to find flexible funding to support creative ideas. So we kind of work along those 3 directions to expand KNI into an intellectual hub. So we partnered with Kavli Foundation. We ran several Kavli Frontiers symposia. So started from 2014, we first ran one on campus. It's called Frontiers in Nanoscience and Nanotechnology, so that we all got together to know what each other were working on. It was really exciting. And then after that, 2014 also, I invited Tsinghua University, a group of professors. They came in for the Kavli Frontiers Symposium. And then the following year, we had a reverse visit to Beijing at Tsinghua University. And then also 2017, I think, was when we actually partnered with industry, with RISE and ZEISS, to arrange a symposium, ion microscopy symposium. I think it was Guy probably took charge of that, and also probably Matthew Hunt also. Yeah, and then 2018, the APS conference, APS March meeting was in Los Angeles. So Kavli Foundation supported us to have this one day of Kavli Frontier Symposium on Condensed Matter Physics. So we invited Nobel laureates such as Duncan Holden and several other outstanding researchers here, and we talk about the frontiers in quantum and topological materials and systems. So that was from that aspect. And then for the support of instrumentation, we actually partnered with Caltech. We got a loan, and also Harry Atwater also supported, helped with that arrangement. We got a loan, so we got our EBPG. We got a new EBPG system. We also upgraded another EBPG system, and we got additional instruments. And then we also wrote a joint proposal to the National Science Foundation to get this helium, neon, gallium focused ion beam system that was state of the art at that time. So we work hard towards that. And then for the funding part, we actually also partner with Caltech and also with the Kavli Foundation. We submitted a proposal to the Kavli Foundation and got support in 4 frontiers in quantum materials to get seed funding, quantum materials and technology, in bio and medical engineering, and in renewable energy and sustainability, and also in instrumentation and technology for space frontiers, and so space exploration. So we got some seed funding for that, and then also we got great support from the Wheatleys. We got Chuck and Judy Wheatley. They helped to establish this prize for junior faculty so that they have no overhead loaded funding, $25,000, I think, to do research. And I think that we already saw 5 outstanding, 5 or 6, maybe six already. Yeah, we just got another one this year. Yeah. So yeah, 6 outstanding people. Some of them are already very well established now. They're no longer junior faculty. So those were things that we were working on. But without what Michael and Axel did, I wouldn't have had the luxury of working on these different things. So anyway, it has been very exciting for me to also be able to access the facilities at KNI. I can do a lot of fun things. Okay, so now
set the foundation, and then so many other things started to blossom, and now today we have the adult KNI carrying the load, paying the taxes, raising the children.
So did you hear a theme about how they all had a partner? All of them had partners. I didn't get one.
I didn't. 3 years later, we decided.
So you understand.
Sharing the blame is a really important thing.
Yeah, I don't have anyone to share anything with, other than my amazing team who's actually here. And so now that I have had the legacy, I think what I'd like to emphasize here is the most important part of any. Running an institute requires operating in a very complex landscape, right? So you're the liaison among everyone, with the students, with the postdocs, with the members of technical staff, with the whole technical team. And then there's this other institute called Caltech that you have to also make your mark within that landscape. So I would say if you all think back to the last 10 years, you can ask yourselves, can we name the last 3 Nobel laureates? Maybe here we can, but most people wouldn't be able to, right? Can we name the last 3 Waterman Award winners or something like that? And I think we'll all think about it for a while. But I think if we ask ourselves, who were the people who influenced my research the most, or who were the people who influenced my life the most, we'll immediately be able to tell. And I think that's what KNI is all about. It's about making these connections on the professional level, on the intellectual pursuit level, and on the level of mentorship, receiving mentorship like I did from all of my predecessors, as well as giving it to whoever comes after you, or who is learning from you and recognizing that you're one of, and that its legacy is much larger than a single individual, or that a single direction. Maybe that's exciting today. And I think that establishing and maintaining this environment where we're not simply renewing the existing capabilities, but we're always looking forward, and we're creating new opportunities, and we do this with the people who influence us, is how I would like to be remembered as the KNI director. I didn't mean to be so dramatic, but...
I have one thing that I want to add here, and that is, from the outset, before 2000, we started with what was called the Nanoscale Sciences Initiative, and Harry was part of that. And in fact, in preparation for this event, I went through my archives, and I found a markup of the proposal. So Axel and I were the chairs of that committee, but Harry was part of it, along with many others. And I found an intense markup from Harry Atwater for our original proposal. So don't be humble, dude. You were absolutely crucial from the outset.
I've been the, maybe, if not one of the, if not the only continuously serving board member, so for the KNI through the entire, since the inception of the KNI.
So thank you.
Yeah. Okay, yeah. Great, well, thank you. So I have the next question. We'll start on the other side with Julia, which is, okay, so Feynman gave us, of course, our plenty of room at the bottom mantra. And in fact, he gave that address in 1959 here at Caltech. It was published in the APS Bulletin. And importantly, he made some challenges to the community. He talked about nanoscience as being something that was pretty far away at that point, but it was definitely accessible. And he had 3 challenges, for example, writing a page of text at the nanoscale, shrinking a motor down to 1/25,000th of the size of a motor at the time. So I have a question for each of you, which is, what would your Feynman challenge be? So suppose today you were to pick a challenge that seems like extraordinary in the sense that it's beyond the current reach, a prize that you would award to somebody for a feat of that scale. It took a while to win these awards or to meet those challenges. And that means they were very ambitious, but they were achievable. So I'm wondering if you have in mind, it's a little putting you on the spot here.
Are we putting me on the spot?
I'll start with Julia. What would your Feynman challenge be?
So I would like to develop materials that can think for themselves. I'd like to build intelligence into materials at the atomic level, and for them to, as the part is being produced, for example, to decide, you know what, I contain too many flaws, so throw me away. Or I have only 3 flaws and I'm going to be okay. I'd like to build that ability at the material level. So not the device, which would be kind of cheating. So not something that gets activated in response to some logic circuit or something like that, but at the material level as it's being created, if we could decide whether self-inspecting material, something like that.
A self-introspective material. Okay, very good. Worthy challenge. Do we have anybody who's going to accept this challenge? Okay, very good. Nai-Chang, what would your Feynman challenge be?
Well, actually, I don't have one specific thing, but it's like an integrated idea. I would think that for nanoscience and technology to further advance, to have maximum impact, we need to, whenever we deal with nanoscience systems, we need to think about scalability, we need to think about controllability, reproducibility, and then of course also functionalities, because like one nanostructure based on certain materials, if we are clever, we can combine different ways of making nanosystems extremely clever, maybe. And then finally, integration or integrability. Yeah, I think to me, I think these are the important challenges that we have to put together and think about.
Yeah, okay. Yeah, I remember an editor of Nature once coming to me and saying, all devices reported in this issue of Nature are currently broken because they were able to be only fabricated once, and they worked for a while the measurements were made, and researchers pushed them beyond the limits of the measurement, and they're now broken. So going beyond this limit is what you're saying. Yeah.
Reproducibility and
exactly, yeah. Okay, Axel, creator of very small things, what is your Feynman challenge?
Well, I think the original goal of the Kavli Institute was to build a nanoscience community where people would make nanostructures. I think what we now do is make tens of nanometer size structures.
Yeah, so we're a 10 nano
on
kind
a
of
good day,
community.
yeah.
Yeah. Or maybe even a 100 nano community.
Yes,
the NSF definition.
And I think there are lots of really interesting effects at the true nanoscale, at the 2 to 3 nanometer and below scale. I think there's some physics that really allows us to do radically different things than what we do nowadays with computers and so on. And I think what is really required is sort of what Julia mentioned, build these systems on the atomic level and probably connect the top-down capabilities that we have, the lithography and etching and all of that, with some bottoms-up capabilities. I think to build that bridge would be really fascinating.
Yeah, it's been long an aspiration of material scientists and engineers to marry top-down and bottom-up,
Yeah.
but it's still arguably an outstanding challenge.
That's exactly what I was alluding to as well.
Yeah.
That's the only way to connect.
There's one other thing, and that is if you really build things at the nanoscale, I mean, this is what the semiconductor industry is finding out, and building things below, say, 3 or 4 nanometers requires a different philosophy than what people have been doing. So it's not just taking the tools that we have and making them better. I think we need to really think about how do we make structures at the atomic scale to do the function that we want. And so that's actually a really interesting and exciting direction, because the things that we're used to don't work at that scale.
Yeah.
And
They're statistical in their nature, yeah.
We will make quantum devices whether we want to or not.
Yes. We won't make them all identical, though, unless we develop these new advances, yeah. So Michael, what would your Feynman challenge be?
So I was glad you mentioned the 3 challenges, in the Plenty of Room at the Bottom talk, because I want to tell you about an interesting backstory for the making a microscale motor challenge. And that was that Feynman said, make a motor, I think it was like 1/100th of an inch in all sides, meaning 250 microns. And a staff member up at JPL, using a microscope and tweezers, made such a motor. And that was not what Feynman was thinking about. But nonetheless, he was an honorable man, so he gave him the $1,000 prize. And it was maybe 30 years later that the field of MEMS, microelectromechanical systems, really became established, and that's what Feynman was thinking about. I would say that my thoughts about the future are, and I gave a talk at our first TEDx Caltech here, I'm wearing the shirt here, about this, embracing complexity. So biological systems are immensely complicated, and to really tease out what the dynamics are, we have to make equally complex systems to interface with them. And so we are very good at doing, like you said, the one-ofs, of doing proof of concept. And we have an incredible palette now of one-of kind of technology.
Yeah.
But to really take this to the next level, to really think about applications that are going to be transformative in many fields, including biology, we have to have a disciplined approach to actually putting these together to create complex systems.
Yeah, we're embracing complexity in so many other areas of science, in neuroscience, biology, AI, and machine learning.
Yeah.
Everybody senses that what will be around 3 years from now will be just vastly more complex than what we have today. And figuring out how to, in the physical world, with atomic scale structures, embrace that complexity.
And I would say, I would appeal to a 1972 lecture, which is, famous now, from Phil Anderson, where he said, more is different. And he was pushing back for the condensed matter community. We, have always embraced complexity, but pushing back against the particle physicists and so that things are different when you put complex systems
Right.
together.
You
New
don't need to go
properties
beyond
emerge.
a diatomic molecule
Yes,
to understand
exactly.
solids. Yeah.
Exactly. So I would say that's an emerging challenge that I think we're on the precipice of really being able to do well. So combining almost atomistic-like structures, but being able to do them en masse.
Yeah. Okay. Great. Okay. So now from the Feynman challenge to the, call it the human challenge. What did you learn? And I'll start with Nai-Chang this time. What did you learn as KNI director about three things: about people, about Caltech, and then also about science as a whole? So people, Caltech, and science.
I learned a lot about what my other colleagues are working on when I was
Okay.
co-director. It was very educating experience for me. I love to learn. I always love to learn new things and create new things. I think that makes my life, meaningful. And the fact I learned a lot about what other colleagues are working on was very exciting intellectually for me. And about people also, we engage students, and that's also an engaging junior faculty postdocs. So those were also very, very good experiences for me. About Caltech, I found out Caltech leadership can be very supportive when you approach them properly. And they can be very supportive. So I mentioned a few things. We partner with Caltech and then Kavli Foundation to support KNI. So that was about Caltech, and I felt that Caltech is really, because of the small size, so we have a lot of flexibility, and that's wonderful. And then, what was the last thing?
No, those were the three. That's good.
Okay.
So maybe I'll ask Axel the same question. What did you learn about science, things outside of your own little bailiwick, about people and about Caltech?
Yeah, so I think when we started, maybe in the 1990s, Caltech didn't have a culture of doing nanofabrication. So I think what I learned about Caltech is that it's tremendously flexible and adaptive. The hope was at the beginning, so both Michael and I came from Belcourt, from Bell Labs, and we had this sort of culture of people making structures day and night, working at night. We did that for a while. And so we wanted, I think both of us, when we came here, wanted to instill some of that culture into bring it with us to Caltech. And I think one of the things that I was extremely happy as a director about was to look at the number of people that were in the lab at night, working after hours, doing things because they were interested in making them work out of the challenge. And I think if you tap into that enthusiasm, we are blessed at Caltech. We get fantastic students that are naturally enthusiastic, self-selection. And so we just need to channel that energy into the right direction. And I think the KNI has been able to do some of that. Did we do it perfectly? No, but I think we're on the way to really take advantage of the talent that we have, the best students in the world, I would say, and match them with the best instrumentation of the world. And I think that should be our challenge. That's what I've learned would be worthy, I think, to establish, and I hope in the next 20 years we'll do that.
Yeah, okay, great. So, Julia, your term is not over, so
Thank you for that challenge for me.
This is the midterm. There will be a final, too. So what did you learn, or what have you learned to date about science, about people, and about Caltech as a result of being director?
Okay, so I'll start with the Caltech part, because I remember very well when I first arrived here in 2007, and the KNI looked like an industrial loft with no walls, with some concrete slabs and rails. There were some metal rails somehow, and then there was one EBPG, the Nova 600, and the Sirion. I think those were the 3 instruments in the clean room, which was definitely not a clean room. And Jan Dion, who was sitting right there, and I were being trained on the Nova 600 on how to use the OmniProbe. And I remember thinking, I'm supposed to be a professor here. What do I do here? And that was in 2007. And so fast forward, not quite 20 years, but now I hope many of you have had a chance to actually check out the KNI. It's a beautiful clean room facility with actual walls, everything, with amazing equipment, with incredible people, and it's a real clean room. So just watching that transformation over my lifetime, over my development from a toddler into a mid-career researcher, has been tremendous. I can't imagine witnessing such a transformation at any other university. What I learned about people is that they're just like materials. It's the imperfections that make them interesting.
Oh, cool.
The people here are very fierce, intense.
Very imperfect.
Yes, very imperfect. Each one is a challenge. Each one's a Feynman challenge, I would say. But we all share this integrity in our commitment to science and our commitment to pursuit. And so I would say that legacy and integrity are my 2 words that I would like to color everything, all of my experiences here. So that's definitely the most special part about being at Caltech. It's the people.
Yeah.
And there was something about science, right? Oh,
yeah. What did you learn? What doors did KNI open for you? New things you learned about science?
Yeah. I think this is probably the key learning. That nanoscale can have the absolute sense, but it can also have a relative sense. So, and it's very important to look at it from both perspectives. So in the absolute sense, making the tiniest structures will enable you to attain some kind of transport, some kind of phenomena, some kind of electronic property. But nanoscale, relative to the other scales, actually offers a wealth of phenomena that I think, that's what I'm interested in our research group, as in for example, adding an extra level of organization into the atomic level microstructure enables you to create new materials with properties that we couldn't have imagined or couldn't have predicted using any computational tool, precisely because we don't have this ability to stack up the multi-scale nature of the complexity associated with just about any material. We understand the atomic level detail much better now. We're able to image it now, we're able to characterize it, and we understand continuum level things. But it's that in between which is represented by the nanoscale that offers such a wealth of new phenomena that we would be interested in. And I think that's why there's the absolute sense, and that's where all the device-oriented people are, that's their playground. But I'm much more interested in the relative scale. And so I think that's my answer.
Okay. And let's see, Michael, I think, what did you learn about science, about people, and about Caltech?
So I just want to preface my comments by again thanking Guy DeRose, who was a staff member, senior staff member in Axel's group, and Axel for having the vision to transform it from this, bare walls to a robust facility that we can all use. When I gave the inaugural talk over at the Athenaeum to Fred Kavli and Dave Austin, the first president of the Kavli Foundation, talking about our excitement and enthusiasm for creating the KNI, I said that, and it's sort of an exaggeration, but the theme is true. I said Caltech is a place where we pretty much have lived in our silos. It's kind of like one professor, one telescope. In physics, many of the professors are like the leaders of various large facilities, but there wasn't on campus at that time shared facilities like the KNI became that enabled our research. And so that was really pivotal. And our focus at the beginning was not only creating the infrastructure for allowing campus-wide us to do nanoscience at scale, but also creating a nanoscience community, a cohort, so we could talk to each other. And I would like to think that our initial efforts in coalescing people, researchers, PIs, led also, was a paradigm for many centers that have since emerged at Caltech. And so our mission of actually, in the beginning, nanoscience was an end to itself. but now it's like integrated into our core research. And so the focus is less on, although that's not taking iota away from pushing forward to the atomistic, it's less now, nanoscience enables us to do our science now rather than being sort of an end in itself. So I would say about people, that's a part about science. About people, I think it created a paradigm for us to emerge from our individual silos at Caltech and really have a community of people pursuing science. And it's been explosive, you know, the developments. I mentioned, Harry, to you before we started that I just came back from a Gordon conference about quantum measurement, and it just, you know, warmed the cockles of my heart to see some of our former alumni, some with gray hair. I'm not looking at anybody individual here, but you know, standing up and speaking authoritatively about research, you know, at the frontiers, and to see this cohort of people. And I'm not talking only about my group. I'm talking about all of our groups. Your group, Jeff Kimball's group, you know, Oscar Painter's group, and others. It's just amazing the footprint that we've had, and being a small part in these amazing individuals' lives.
Yeah,
who
creating
are now,
a community.
Yes,
Yeah.
exactly. What
Yeah.
was the third thing you wanted? Did I cover it?
Yeah, about science, people, and Caltech, and I think
I covered
that's
it.
good. Yeah,
Yeah,
you got
okay.
it. All right,
Thank you.
You met the moment. Okay. So okay, now
Uh-oh.
we're gonna for our sort of
I didn't read the email, so I don't know
yeah.
what's going on.
Okay. So I'll give you a moment to think about this because I'm going to push you out of your comfort zone a little bit. And so first of all, I need to let you in on everyone in on a secret here, which is that, of course, you know we have the thesis prize at Caltech. We have a thesis prize winner, Jen Dione, who won the thesis prize.
Raise your hand.
And
She's
so,
not here.
okay.
Okay.
So
Raise my hand for her.
and so when and it was the Milton and Francis Clauser Prize, and at the time that I had the experience of being involved in this committee, the late Francis Clauser was running the committee, and he did it in the following way. He said, "You get to vote for a candidate, the best candidate among this group, other than your own." Okay?
That's great.
And so what I want you to think about and tell us, what is the nano world other than your own research area, some other research area, this is really hard, okay, other than your own that we should explore next? What nano world other than your own should we next explore? What's the next frontier that you're not working in, you don't have heritage, but you're looking at and thinking, wow, that would be an interesting thing to jump into? Take a minute here. One of the characteristics of Caltech faculty is that they're able to make these leaps.
Okay.
Well, I've seen it with you. You've gone from electronics to nanomechanics to biology and neuroscience. So you're exhibit A here. So, but any takers here? In any order. Axel's going to.
Yeah, sure. So I think it's neuroscience, which
Okay.
I'm not working in. But Michael is, and the complexity that we have to deal with in neuroscience is so challenging that miniaturization and miniaturized devices are going to be necessary at a scale that is amazing. That we can't, so if you think about the modern tools of neuroscience, you're sampling 84 billion neurons with 10,000 probes, undersampling.
And it's, of course, a very challenging environment in which to make measurements, right?
Very difficult environment, very difficult to get information in and out.
Yeah.
But I think there is a fantastic opportunity for nanoscale devices to address this challenge. And it's the ultimate challenge of understanding ourselves. Okay, so it's like, what makes us tick? Okay, it's the introspective journey that I think we really must go through. In order to understand ourselves, we have to understand our brain. And so I applaud the things that people are doing in neuroscience, but I think it's the Stone Age compared to what we need to be at.
To where
Okay.
we to really realize this aspiration. Yeah. Okay, that's a great great reflection. So another taker, Nai-Chang is okay.
You say that we have to stay out of our field, but I would say I'm only working on a tiny bit of something I'm going to say.
Okay.
And so that should still be
Fair
fair. Yeah, I am excited about the quantum frontiers, and I think, and that involves many things. Quantum computation we have heard today, quantum sensing, and of course quantum networking. I think all of these are going to totally revolutionize the future of science and technology. So I'm only working on a tiny bit of this big picture. But I think this is a frontier that has many challenges. It also involves materials. We need to have the very best. So far, we don't have the best materials for qubits, and that's why people have to work so hard. So if combining, I often wonder if we can combine AI capabilities to analyze a lot of data, a lot of materials. Perhaps we could figure out a way of creating our own materials, not necessarily synthesizing some materials from scratch, but functionalize things that could really fulfill the bill of the requirements. So that would be what I would love to see happening partially in my lifetime.
It's going to require the atomic scale control that Axel was talking about as well. In essence,
Precision.
atomic scale engineering.
Mm-hmm.
I think that's a great. So Julia, what is your field other than your own?
Okay, well, I want to save the planet. See, I think that people are the problem, so I'm actually not. I'll leave neuroscience to you guys. So I think that what's really exciting for me would be finding pathways to harness and harvest energy using using nanoscale phenomena and using nanoscale materials from the ocean, from the sun, from you are the expert here, from a variety of different natural resources that are abundant, that are free, that are available to us, and then making every effort to save the planet first, and then go from there. So I'll keep it short.
In the morning,
With
save
the
the
big
planet.
goal of saving the planet. So
Before
we're going
lunch,
to.
then go on to the rest of the agenda. Okay,
Exactly.
Very good. Fantastic. Okay. So Michael, what is your challenge?
You're going to like this one.
Okay.
I heard, so I just got back last night from this Gordon conference I was telling you about, and there was an insanely inspiring talk, and I think it was using megawatts of laser power and gram scale payload projectiles.
Where did that come from?
Yeah, made out of photonic crystals to reach the edges of our solar system in hours and reach in our lifetime Alpha Centauri, right? So these aspirational things, okay, maybe we'll never get there, but we should try, And it's very exciting to think that the technology that we're all working on could actually allow us to have not a moonshot, but a star shot, right? Awesome.
Okay, great. Love that one.
I know, because you're working on it, right?
Yeah, okay. So parting thoughts.
Parting thoughts?
Parting thoughts not from, but from the panel, that is.
Oh, okay.
Parting shots.
What kind of, are we leaving? Okay. To conclude the panel?
Well, we're coming on to the end.
Yeah. I just want to express tremendous amount of gratitude to the Kavli Foundation, to Tiffany, to Guy, to the entire KNI team, to Axel and Michael and Nai-Chang and Oscar and to Harry and all the other board members who are, I'm not sure if any of them are here. It's a village, and it's been a privilege to work in this. It's been a challenge and a privilege, and I really value all of the support and all of the interactions and just being a part of this. Feel very lucky every day. So thank you. I think that's it.
And Nai-Chang?
I hope that KNI can continue to attract the best talents. It can be a facility that can attract the best faculty, students, postdocs, and can continue sustain wonderful state-of-the-art facilities, and also can nurture the interactions among Caltech nanoscience community.
Well, I'd like to thank the people that have made the KNI what it is, and particularly Guy DeRose, who's actually sitting there trying to make the trains, leave on time when the trains are completely irrational and impossible to predict. We are in a very unusual situation that we are trying to make this fantastic clean room in a small campus. And so there are lots of challenges. But I'd like to thank the people, the people that devote their time to making the KNI and the laboratory what it is. I think that also includes the students and postdocs that are in there that probably teach each other more than we could ever teach them. And I think that's the beauty of doing this as a laboratory, a joint laboratory. What happens at night when one of the students teaches another how to do certain processes in their thesis, I think that is invaluable. And in fact, that's what makes Caltech what it is.
So I want to thank the presidents and provosts that have been in charge during the 20-year tenure of the KNI. And Harry, you know well, especially since you're in the administration now, that we have been intense irritants, each of the KNI directors to the... Oh, you're totally sweet. We know this. To the administration, to press, for the ideals that we all share in common. And it's really important to step down as the director from the KNI when, people are looking at, oh, there's Roukes again, his mouth is going, what is he saying, right? And then it takes somebody else to actually start saying it. It's the same thing, but a different person. But I want to go back to what Axel said too. What a privilege to be a professor at Caltech, to hire people that are smarter than you are, to learn from them. So really the success of the KNI and all of us individual professors is this incredible student body down to the individuals that teach us things, do the hard work, and really, carry the banner and carry us into the future. So thanks to the students.
Okay, amen. Yeah, thank you very much. So.